Today, I am going to be looking at data collected in 2015 by the U.S. State Education. And we have the table and a map and a plot of our data here, but I don't need this text box. So I'm going to get rid of that and reorganize things so I can see the whole table. I can open that up. And I can move the map over here. Move the graph. And so we are going to be doing an investigation into the south and west regions. And so all of our data points are over here, but I don't want to look at all of it. So I can organize this. And so we have Midwest, Northeast, South, and West on the bottom. And I can highlight all of these data points, which show up blue, and I can hide all of those. So then now on my graph, all I'm looking at are the south and west data points. So I can simply click, drag, and drop what I want to look at. So because we only have the south and west data points, those are going to be organized by region on my y-axis. And then we are going to look at average salary first. So if I were deciding which region I wanted to work in simply based on average salary, I can take this graph and I can look at some measures to see what I would decide. So first I can see that the mean is larger in the west than it is in the south. And so if we put a box plot on here, well, I can see, first that the interquartile range is much larger in the west than it is in the south, spanning much farther and much higher than it does in the south. And so there's a lot more variability, but also a greater chance, since 50% of my data is above where it is in the south, that I will get paid more if I work out west. So if I'm basing my decision off of average salary alone, I would say that I would prefer to work out west. Now, nobody makes a decision based off of one aspect, and using this technology, it is very easy for me to change the data that I am looking at and examine another attribute by simply moving it over and changing my entire graph. And again, we have the expenditure per student, and the mean is larger in the west than it is in the south. But it looks like the main 50% of the data for both of these falls right around the same category. However, more of the data is weighted heavier on the higher end in the west than it is in the south. And so again, if I were using this to make a decision, I would say that this leans me towards moving out west. And if I want to, I can type in average salary west, and then I can type in expenditure per student west, so I can keep track of each item and the decision that it has led me to make. So we can look at number of teachers per student, and not number of teachers per student, number of teachers in the region. And so the mean in the West is 47,616, and the mean in the South is 73,850. So there are fewer teachers in the West than there are in the South. Now, in context, that could mean a couple different things. So if there are fewer teachers out West, then they might be looking to hire more. Whereas in the South, if there are already more teachers, then it might be slightly more difficult to find a job because there's already a lot more teachers. So we have to look at the context of these numbers that were given in order to make a decision. So again, I would say that since there are fewer teachers out West, they might be short on teachers, and so it might be easier for me to get a job out there than it would be in the South where they have more teachers. And so we say number of teachers and we will say that our decision was in the West. And I can continue this analysis, but we'll just look at one more thing. We'll look at number of students per teacher. And so immediately I see the box plots are giving me a lot of information. This is showing that there is a very wide range for the middle 50% of the data in the West, whereas in the South it's a very small range, and it falls within this bottom portion of the West. So all this data is very close together and grouped very close together. And so the median is 15.2 and the mean is about 15 in the South. And then in the West, the mean is 17.6 and the median is 17.9, so about 18. But this data is much higher in the West, and all the data points are much more spread out, and a lot of them are much higher in the West than they are in the South. So in this context, I don't want a higher number because I would rather have fewer students in my classroom than more. So I would choose the South because I would much rather have a smaller classroom where I can pay attention to more students than a classroom with more students where my attention is going to be stretched thin. So we will say students per teacher. We will say that the South won that one. So out of four attributes that we've looked at, 3 of them have led us to the West, and 1 of them has led us to 1 each down. So I would say that overall, my decision would be to work out West. And now there are a couple more attributes that I could look at. But at the moment, my decision is leading me out West. But I was quickly able to change graphs and examine the data very quickly using box plot here, which showing me the median and the interquartile range and the mean. And I could also overlay another attribute if I wanted to look at that as well and examine that. So looks like high school graduation rates are a little bit lower in the West than they are in the South because there's more darker colors in the South than there are in the West. The West only has a few darker circles. So graduation rates might be higher in the South as well. And this is something that I can easily use this technology to change the graphs and look at different aspects and at different attributes with just a simple drag and drop. So I would personally choose to teach out West simply based on average salary and then also based on my examination of other attributes that were given to me in this data set. So thank you very much, and that is all I have for today.